Hello champions, welcome to the Bhanzu class. I hope you all are doing great and are super excited for the session, right? So let's quickly begin the session. But students, before I'll tell you the topic of today's class, let us quickly recall about exponential form of numbers. So we have seen that in our day-to-day life, we are dealing with very large numbers like speed of light in vacuum, diameter of earth, distance of sun and earth, right? So in all these numbers, whenever we are dealing with such large numbers, it is difficult to read and write it, right? So what we can do? We can simply represent these numbers with the help of exponents. For example, the speed of light. What is the speed of light in vacuum? It is 300 million, right? But if I'll express this number in the form of exponent, it will be written as 3 into 10 raised to the power 8, right? So it is very convenient to represent these large numbers in the form of exponents. So that is what we discussed in the previous slide. Wonderful. Now it's time to do a little brainstorming here. So let us see the question. Let's think, how will you simplify 2 raised to the power 3 whole raised to the power 2? How will you solve this question? Think about it. Okay, I will help you here. I will teach you a concept of laws of multiplying and dividing powers with same base, which will help you in finding the solution. So let's start. So in this session, students, we are going to learn multiplying powers with same base, then dividing powers with same base, and then taking power of a power. So the first is multiplying numbers with same base. Okay, so let us take one example of this. Let us say we have to solve 2 raised to the power 3 into 2 raised to the power 2. Okay, multiplying numbers with same base. So here our base is same, that is 2, and the powers are 3 and 2. Now how we will multiply it? So let us see the expanded form of it. We can write it as 2 raised to the power 3 can be written as 2 into 2 into 2, means 3 times 2, right? And 2 raised to the power 2 can be written as 2 into 2, right? Now I can write this as 2 into 2 into 2 into 2 into 2, means I am multiplying 2 5 times. So I can represent it in the form of an exponent, that is 2 raised to the power 5, right? So can I say that when we are multiplying numbers with same base, we can add the exponents. It means 2 raised to the power 3 into 2 raised to the power 2 can be written as 2 raised to the power 3 plus 2. So it will become 2 raised to the power 5. Alright. So students, here we can generalize this and we can write this formula as a raised to the power m into a raised to the power n can be written as a raised to the power m plus n, where a is a non-zero integer and m and n are whole numbers. Alright? Wonderful. Now let us see the next topic here. Dividing numbers with same base. For example, if we have 3 raised to the power 7 divided by 3 raised to the power 4. So how will I write it? I'll write the expanded form of it. That is 3 into 3 into 3 into 3 into 3 into 3. So how many times I've written? 1, 2, 3, 4, 5, 6 and one more time. That is into 3. Right? And then I'll expand 3 raised to the power 4 also. So that will become 3 into 3 into 3 into 3. 4 times. Right? Now when I solve this, students, what will I get? This will be cancelled with this and this will be cancelled with this. Right? So what I'll get here? I'll get 3 into 3 into 3. Means 3 times 3. Which can be written as 3 times 3. Alright. So can I say that when we are dividing numbers with same base, we can subtract the exponents? Means 3 raised to the power 7 minus 4, which will give me 3 raised to the power 3. Right? So here also we can generalize this and we can write that a raised to the power m divided by a raised to the power n can be written as a raised to the power m minus n, where a is a non-zero integer and m and n are whole numbers such that m is greater than n. Alright? Wonderful. Now, taking power of a power. How we will solve this? Let us take an example. Let us say we have 2 raised to the power 3 whole raised to the power 2. So how we will solve this question? It means we can expand it and write it here like this. 2 raised to the power 3 into 2 raised to the power 3. Yes or no? Yes. And 2 raised to the power 3 can be further expanded as 2 into 2 into 2. Right? And similarly, this also I can expand and write as 2 into 2 into 2. Now we know that on same base we can add the powers, right? So can I write it like this? 2 raised to the power 6. Alright. So how can I write this? It can be further written as 2 raised to the power 3 whole square can be written as 2 raised to the power 3 into 2. And that is equals to 2 raised to the power 6. Alright. So here also we can generalize this and we can write it as a raised to the power m whole raised to the power n can be written as a raised to the power m into n. That is a raised to the power mn. Where again a is a non-zero integer and m and n are whole numbers. Alright. Now let us see the application part of it. Remember the brainstorming question? 2 raised to the power 3 whole square. How we will solve it? So we can simplify it and we can write it as 2 raised to the power 3 into 2 raised to the power 3. Okay. Now we can use this law of exponent that on same base on multiplication we can add the powers. So this will give us the answer 2 raised to the power 3 plus 3, which will give us the answer 2 raised to the power 6. Alright. Also we can use one more law here, that is a raised to the power m whole raised to the power n is equals to a raised to the power mn. So using this also we can solve this question. So 2 raised to the power 3 whole raised to the power 2 will become 2 raised to the power 3 into 2. That is again 2 raised to the power 6. Alright. So we can use any of the law to solve this question. Wonderful. Now it's time to practice some more questions here. Let us see the first question. We have to solve 5 raised to the power 3 into 5 raised to the power 7 into 5 raised to the power 12. How we will solve this question, students? Which law we will use here? We'll use this law that a raised to the power m into a raised to the power n will give us the answer a raised to the power m plus n. Right? So we have the same base here, that is 5. So I'll write 5 here and I will add all the powers. So it will give me the answer 3 plus 7 plus 12. And what it is equals to? 10 plus 12, 7 plus 3 is 10 and 10 plus 12 is 22. So our answer is 5 raised to the power 22. Alright. So this is how we will solve it. Let us see the next question here. 7 raised to the power 13 divided by 7 raised to the power 10. So we have to solve 7 raised to the power 13 divided by 7 raised to the power 10. So which law we will use here, students? We will use this law a raised to the power m divided by a raised to the power n can be written as a raised to the power m minus n. So on same base, if we are dividing, we will subtract the powers. So it will become 7 raised to the power 13 minus 10 and which is equals to 7 raised to the power 3. Alright. So this is our answer here. Okay. Now let us see the next question. Can you tell which one is greater? 5 square raised to the power 3 or 5 square into 3? So how we will solve this question, students? We have to write the expanded form of this, right? So let us see how we will solve this. 5 square into 3. Now what is 5 square? 5 into 5, that is 25, and 25 into 3 is 75. So this will give us the answer 75. Now let us solve this. 5 square raised to the power 3. So here we can use this law of a raised to the power m whole raised to the power n can be written as a raised to the power mn, right? So I can write this as 5 raised to the power 2 whole raised to the power 3 can be written as 5 raised to the power 2 into 3, which is 5 raised to the power 6, and which is nothing but 15,625. Now we have both the values, we can compare it. So which one is greater? 15,625 or 75? Obviously, 15,625 is greater than 75. So we can say that 5 raised to the power 2 whole raised to the power 3 is greater than 5 square times 3. Alright? Wonderful. Now it's time to summarize what we have discussed in today's class. So let's quickly do it. So students, here we have discussed various laws of exponent. So the first law that we discussed here is a raised to the power m into a raised to the power n will give you a raised to the power m plus n. It means when we are multiplying on same base, we will add the powers, where a is a non-zero integer and m and n are whole numbers. Alright. After that, we discussed the second law, that is a raised to the power m divided by a raised to the power n will give us a raised to the power m minus n, right? Where a is again a non-zero integer and m and n are whole numbers such that m is greater than n, right? And then we discussed taking power of a power. It means a raised to the power m whole raised to the power n can be written as a raised to the power mn. Okay, it means a raised to the power m into n. So these laws we discussed in today's class. Wonderful. So that's all from today's class, but there is much more to discover about exponents and powers that we will do in the next video. Thank you so much, students, for joining the session. I will see you in the next video. Till then, keep learning, keep exploring, and spark your curiosity. Bye-bye.